ways you can prove angles congruent, guys, we've already had several. One of the major ones is going to be what this very first slide is about. It's about vertical angles over and over and over again. When you deal with vertical angles, they are always going to be congruent, but you've got to recognize that they're vertical to be able to do this. You're going to look at all 4 of these examples. First thing I want you to do is go through and mark the ones that are congruent. You can see this angle would be congruent to this angle because they are vertical. Vertical angles are formed by intersecting lines and they are directly across from each other. The next pair, these 2 would be vertical angles and would be directly across from each other, so they'd be congruent. Guys, just because it has this doesn't make it not intersecting lines. It's still intersecting lines. These 2 angles would still be the 2 angles that are congruent to each other. Are there others? Yes, these 2 would also be congruent, but those aren't the ones we're trying to work with. And even inside of a rectangle like this, you have these 2 angles formed by these intersecting lines, and those 2 would be congruent to each other. Which means for all 4 of these problems, what are we going to do with these 2 amounts? What would I add them up and set them equal to? Or do they make a straight line? No. What did we just say about all 4 of them? They're what to each other? The same, congruent, all correct. So what would you do instead of adding them up? Say it. You got it.
2x plus 3y
Wait, equals, yes, sorry, you were doing the last problem. I was looking at the first one, so I was really confused where you got that from, because see how they both have a 2x plus 24 on them? I was completely confused. She's 100% correct. Guys, set them equal to each other. You just told me they're equal, set them equal. There you go. They're congruent, therefore we can set their measurements equal. 6x is going to equal 2x plus 24. Good deal. Solve this. Minus 2x minus 2x. That would make it 4x equals 24. Divide by 4, and x would equal, what's 24 divided by 4? 6. Do I need to plug it back in? Why not? It's correct, but why not? Doesn't ask me to. And you've got to read what it asks you for in geometry. This only asks me to find x, so my answer is x equals 6. That's it. That's my answer. I'm done. Okay? All 4 of these are done the same way. So let's do another one. 17 plus 3x equals negative 4x plus 31. Okay, I have a question real quick. Does it matter which one you put on which side? They're equal. No, it doesn't matter at all. Symmetrical property of equality says you can switch the sides of the equal sign across an equal sign and it's still the same. It doesn't make any difference. Let's solve this one. Plus 4x. Plus 4x. Now, I will say this, guys. Since there's an x on this side, line it up underneath the x so it's like terms. This cancels out. I'm going to get 17 plus, and then it's going to be 3x plus 4x would be 7x equals 31. All I did was cancel out that 4x, guys, and I added the 3x and the 4x. Now what do I have to move? The what? I wouldn't move the 7 because it's got the variable on it. What would I move next? 17. How do I get rid of a positive 17? Yep, subtract it, minus it, however you want to say it. It'd be 7x equals, what's 31 minus 17? 14, thank you. Make life easy. Appreciate that. Then you divide by 7. Perfect. Y'all are doing great. There we go. Any questions on solving that one? What would the next one be? Perfect. Now, guys, this one's a little bit different. This is the first one where we've only had variables on one side. That should make it easier, but you'd be surprised. Sometimes that messes people up. Since we've already got all the variables on the right side, we need to move the numbers over here. So the 13 is what we're going to move first, and we need to move it over. So we're going to minus 13 minus 13. That cancels this out. I get 40 minus 13 would be 27. Check my math, guys. Yes? Okay. and then divide both sides by 3. 27 divided by 3 would be 9 equals x. Yeah, well, I'm doing this on a calculator. Make sure you check my math. Are we good? Is that correct?
Yes, correct.
It's correct? Okay, I just want to make sure. Okay, guys, last thing, last one like this, then we'll go to our proofs. Guys, this is a lot of what the first 6 problems, actually the first 9 problems are like this. You don't get to the proofs till the backside, and it's only 2 proofs. It's just enough to practice the proofs. So most of your problems are going to be like this. And guys, do you see that all of them are set equal to each other if they're vertical? Now, they're not necessarily all going to be vertical because they may use old stuff. And if there are 2 of them, like that we talked about earlier, that make a straight line, what does every straight line add up to? Ooh, listen, what does every straight line add up to? 180. If you get one like that, it adds up to 180. But the new stuff, all going to be set equal to each other. Yes?
Again, how would you know if they can run that?
How do I know they're congruent? By the definition of vertical angles, period. The definition of vertical angles said if you have 2 angles that intersect, 2 lines that intersect each other, the angles that are across from each other will always be congruent. So those 2 would be congruent, and these 2 would be congruent. So based on that definition of vertical angles. Good, thank you for asking me how do I know. That's the key in geometry. How do you know? Okay, last one. Do y'all have an answer yet for it? Don't say it if you do, but do y'all have an answer yet? Okay, get it done. Let me try it. I'm going to try it. I'm not even going to say it. I'm not going to walk through it. I'm just going to get an answer and see if y'all got it right. Let's see. Okay, did y'all get 20? Yes? Okay, good. I'm going to leave it up there a minute. Make sure everybody's got it. I'm not going to rush through. I just wanted to see if I could get to what y'all got. And x equals 20. See if we've got that process down. Anything about that before I go to the 2 proofs? Because you're going to have 2 proofs on your homework. They're very similar to this. It's going to be the same process. You're going to have to use all those things, those properties off that last set of notes. We don't have new properties. We're just applying them. Anything you need to ask about? Anybody still writing? No? Okay. Here we go on this first proof. This is our first one. So this first one is example 5. Guys, do you see that only one of these is missing for our statements? And then we've got this one for a reason, this one for a reason, and this one for a reason. That's what we got to fill in. What's missing? So here's the way you walk through a proof. You get the given information right here. It says angle 6 is congruent to angle 2. Where do we put that? You put it in the statements where it says given. So it's going to go right here on number 1. Angle 6 is congruent to angle 2. And then listen, this is geometry. We draw on our picture. To be able to go through this process, you need to write on your picture. Mark congruent, angle 6 and angle 2. Mark them congruent. I'm telling you, you've got to write on your picture. The next thing it says is that angle 2 is congruent to angle 3. Mark it. Angle 2 is congruent to angle 3. Guys, how do we know those 2 are congruent to each other? We just talked about what kind of angles those are. What tells me 2 and 3 are congruent to each other? They are what kind of angles? Good. So definition of vertical angles. They can also say vertical angles are congruent and just literally write the definition down. But definition of vertical angles or vertical angles are congruent, I will take either one. So you see it both ways. Okay, now guys, listen, I'm switching highlighter colors to see if we can make this happen. Do y'all see that angle 6 is congruent to angle 2? Okay, 2. Do you see that angle 2 is congruent to angle 3? Because they're both congruent to angle 2, then they've got to be congruent to each other. 6 would have to be congruent to 3. That's that transitive property. If something is congruent to the same thing, 2 things are congruent to the same thing, they've got to be congruent to each other. If, then this. So that's going to be that transitive property of congruence. The next one says that 6 is congruent to 7. Look at your picture, guys. How do I know 6 is congruent to 7? Straight across. It's straight across. What's that called? What kind of angles are straight across from each other? Come on. What kind of angles are like this? Two angles right across from each other, formed by intersecting lines. What kind of angles are those? Vertical angles. So it'd be definition of vertical angles. Definition of vertical angles. Okay, guys, I'm going to do some highlighting again, but I'm going to erase so you can see just very clearly. This was angle 6 congruent to angle 2. Okay, here we go, guys. How do I know that 3 is congruent to 7? Well, look right here. 6 is congruent to 3. 6 is also congruent to 7. Therefore, if they're both congruent to 6, then they've got to be congruent to each other. What property is that? There you go. Transitive property of congruence. And Phoenix, since I know you missed a bunch of stuff, I post everything that I do. Literally everything I do on Canvas, it looks like this, just so you can see it. So when I post something, like the notes I gave in my algebra class, I've already posted the video for them. So if you need to, like, if you feel like you're missing something that you didn't get, like you missed from your other school or you haven't seen before, you can always go back and look at any of the videos on there. And this comes up as soon as you join Canvas. Did you get a Chromebook yet, Sweetie?
I already got one.
You have one? Awesome. Then you should be able to access that page. And if not, let me know, okay? Okay. This is what Canvas looks like for mine. It shows up like this. It's the one with the big red car right here. And then when y'all see it, literally that calendar's there with everything in it that we do. And it like even has stuff all the way through the end of the 9 weeks. Okay? Okay, guys. So back to notes real quick. I just want to make sure you saw it. Last thing is going to be this this proof. Let's walk through this one. A little more involved. It's got named angles by letters instead of by numbers. It's a little more complicated to name it like that. So let's get going, guys. The first thing is the given statement. Angle Y is congruent to angle ZXY. So here's angle Y right here. Angle ZXY. Guys, the middle letter tells you where this angle is at. ZXY is right here. Those two angles are congruent to each other. That was given to us. It then says that ZXY, that same angle, is going to be congruent to angle VXW. Angle VXW starts at V, goes to X, and then goes down to W. So that's this angle right here. These two angles are congruent. Guys, they're across from each other. How do I know those two angles that are directly across from each other are congruent? What kind of angles are formed by intersecting lines directly across from each other? Vertical. So definition of vertical angles. Okay, for this next one, do you see that these are both congruent to angle ZXY? If they're both congruent to ZXY, then they've got to be congruent to each other. What property says that? Transitive. Nice. Transitive. Property of, is it congruence or equality? Congruence. How do we know that? Because we look at the symbol right here. Is it a congruent symbol or is it an equal sign? If it was equals, we put an equal sign. If it's not, it's congruence. Okay. And you'll see it changes right here. Watch, guys. Watch. You see it goes from having the actual angles, bless you, to having their measures. We're replacing the angles with their measures. If we're replacing those things, okay, if we're replacing those things with their measures, if we're saying that because they're congruent, they're now going to be equal to each other, okay, that's just going to be the definition of what kind of angles. What does this word, this symbol right here mean? What's that symbol mean, guys? You can't do this class if you don't know what that symbol means. Come on. What does this mean right here? Congruent. Those are going to be congruent. This one is going to mean equal. So we're going from congruent to equal. How do we know that? By the definition of congruent angles. That's something we've had already. They expect you to know that because they're congruent, they're equal. Because they're congruent, they're equal. Now, instead of putting their measures, we actually put the measurements in there by replacing what's in the picture. We're taking this and we're replacing it where the y is right here. And we're taking this and replacing it where the VXW is on this side. If we're replacing it with that new thing, what is that called when we replace? Substitution. Very nice. Subs, if I could spell, substitution. Property. Now, am I doing it for the whole thing? Am I doing it all the way across the problem? Have I replaced everything? Yes or no?
No.
Did I replace everything on this side with this? Did I replace everything on this side with this? Yes or no? Look. Guys, did I replace everything over here and everything over here? Yes. If I replace everything, I need to put of equality because I did it all the way across the problem. That's how I know whether to put that or not. Did I replace everything all the way across? Okay, guys, the last part is solving. How do I move this 2x to the other side? Minus. If I minus 2x, that's going to be the subtraction property of equality. Subtraction property of equality. Now they're already telling you on the next step you've got to subtract again. The next step is also subtracting. What are they subtracting to get the 3x by itself? The 20. Minus 20 minus 20 would make the 20 cancel out. We just get the 3x all by itself. And 50 minus 20 would be 30. There's that step. And then what do you do to go from the 30 equals 3x to 10 equals x? What are you doing to both sides? Dividing by 3, which is the division property of equality. Perfect. Division property of equality, guys. Nicely done. Okay, guys, literally.